Let's take a look at the general gas law. The general gas law is a combination of the of both Boyle's law, Charles law, and the pressure law. Yes, it yields the general gas law in the sense that if the three laws are combined together, if they are harmonized, we have PV over T to be equal to constant. That is P1 V1 over T1 equal to P2 V2 over T2. Yes, the general gas law. So let's quickly take a question under this law. We have a question before us that says that a given mass of an ideal gas occupies volume V at a temperature T and under a pressure P. If the pressure is increased to 2P and the temperature reduced to half of the initial, which is T, then what is the percentage change in the volume of the gas? We have the option here. So as usual, let's solve and see which option will be in line with our answer. Solution. So we are going to apply the general gas law to this because both volume, temperature, and pressure suffice in this question. So we're going to use the general gas equation. We have to find the percentage change in the volume. That is the final volume minus the initial volume divided by the initial volume multiplied by 100%. Now, why are we doing final minus initial? It is because this is a compression. You see that the temperature is what? Reduced. It is a cooling, so it's compressing. So the final volume is going to go. So yeah, the final volume is going to be more than the initial volume. Or instead, you can solve it the normal way and say V2 minus V1. Just that at the end of the day, you neglect the negative answer, telling you that what? It is a reduction in volume. Okay, so from here, our P1 V1 over T1 equal to P2 V2 over T2 simply means that our T1 is T, V1 is V, and P1 is P. That is PV over T equal to P2. The second pressure is increased to 2 times, that is 2P. P2 becomes what? 2P multiplied by V2. Our V2, that is what you are looking for, unknown, all over second temperature. The temperature was reduced to half, 1 over 2T. 1 over 2T. So without being told, these two comes up and we'll be left with PV over T equal to 4PV2 over T. That is 2 times 2 will give us 4 there. So temperature cancel temperature, P cancel P, and I think the V2 is equal to V over 4. So that's our second temperature. Now, the percentage increase now, percentage change in volume, percentage change in volume will be equal to initial minus final divided by initial times 100%. So, which will give us the initial minus final divided by initial, V minus V over 4. We're going to have 3V over 4 and have 3V over 4 divided by V to multiply by 100%. So 3V divided by 4, V we cancel V, we have 3 over 4, so that our percentage change in volume will be equal to 3 over 4 times 100%. And 3 over 4% simply means 75%. Sorry for the tight work. So which corresponds with the answer here, option C. So that is that for that aspect. So let's see question number 2 that says that the pressure of a given gas changes from 300 Newton per meter square to 120 Newton per meter square, while the temperature drops from 127 degrees Celsius to negative 73 degrees Celsius. What is the ratio of the final volume to the initial volume? So in this question, it is also a compression, but we have to find V2 over V1. This is what we have to evaluate. So from our general gas law, P1 V1 over T1 will be equal to P2 V2 over T2, which simply means that we can have our V1 over V2. I will just bring this V to this place, bring this one here, and this P to the downside here. So V2 over V1 will be equal to our P1 T2 all over P2 T1. So this is what I'll have. And conversely, V2 over V1, I'll start substituting. What's my P1? I'll check the question. changes from this to this. So my initial pressure is 300 multiplied by T2. My second temperature, final temperature, this is minus 73 degrees Celsius. In Kelvin, that will be what? Minus 73 plus 273. That's in Kelvin. Then divide by my P2, final pressure, 120. 120 Newton per meter square multiplied by my, yes? I think I might have, yeah, that's my T1, initial temperature. Initial temperature is 127 degrees Celsius. 127 degree plus 273. So we'll see that at the end of the day, V2 over V1, which is the ratio, will be 300 multiplied by minus 73 plus 273 will give us 200 divided by 120 multiplied by 127 plus 273 will give us 400. So this cancels this cancels this, 0 cancels 0, 12 here we have 5, 2 here we have 2. So at the end of the day, technically we have 5 over 2. So the ratio V2 ratio V1 is equal to 5 ratio 2, which corresponds with option